All right, guys, I already pre-filled this one in. So if we are talking this top bit, it's still talking unit 1. But in terms of chemical properties, things that have to do with the chemical nature of what you're talking about, we could talk about the heat of combustion, the pH or pOH, electrical conductivity of the material. If we're talking about physical properties, they're properties that have not to do with its chemical nature, but its physical nature. So it could be its color, what its melting point is, what its boiling point is, what its phase of matter at room temperature is. Those would all be physical properties. So if you change something chemically, you make a chemical change. And so that could be if a chemical property is pH, then changing the pH would be a chemical change. If heat of combustion is a chemical property, giving off heat due to combustion or giving off light, we can do both, those would be chemical processes causing a chemical change. Physical changes then go back to these physical properties. If something melts, if it was ice and it melts, it's still water. If it was liquid water and it boils, it's still water. Those would not be chemical changes, they're just physical changes in the state of matter. And also things like changing shape. If you turn something to a powder or you roll it into a ball or one of those things, those are just changes not in the nature of what it is, but in the shape or appearance of the thing. All right, we did triple point graphs and we did phase change graphs both in Unit 1 and in Unit 9. So if we look at our triple point graph, and you might want to go ahead and label that, we have these high temperatures and high pressure. That means that this area must be our gas or our vapor. We have these low temperatures as we go this way, low temperatures and low and high pressures, excuse me, this must be our solid. So this middle bit has to be our liquid. If I go at this pressure and I go add heat, add heat, add heat, add heat, I'm going to go from solid, then I'll melt, and then as I add heat, then I will boil, and now I'm a vapor. If I did this at a lower pressure, way down here, now I'm going to be a solid, and now all of a sudden instead of melting or boiling, I am going to sublimate. Remember the word sublimate means going straight from a solid to a vapor, and we're skipping this whole liquid. This little point where all the lines meet at that temperature and that pressure, that is our triple point. This point way up here, the last little point on that line is called the critical point. All right, this graph shows us at STP heat as it's added and temperature as it changes. And this would happen to be for water. And I can tell that because it melted at 0 and boiled at 100. So water below 0 is ice. This first diagonal line indicates ice. This first plateau where temperature quits changing. So what's happening? All the molecules of the ice are bonded together, and they're bonded together tightly enough that they can vibrate in place, but they can't vibrate too much. And so they get to this point, they need to get any hotter, it needs to be able to vibrate more. So now we have to loosen those bonds up. We're going to loosen the intermolecular bonds, the bonds between molecules, and then we're going to finally loosen them enough that we are now a liquid. So we melted. And now we heat the liquid up. We're moving those molecules in the liquid faster and faster. And they can move fairly freely because it's fairly loosely bonded, but it still gets to a point that it can't move anymore. So now we take this whole bunch of energy to totally remove those bonds. So those liquid molecules are moving as fast as they can until we remove the bonds by boiling or vaporizing. We can call it either term. And now we finally have a vapor. If you look over here at our temperatures, I've labeled the melting point, which is that first little plateau, and the boiling point, which is the top one. If you need extra information on this, check in your Unit 9 and Unit 1 notes. Okay, some compounds different from elements. Well, an element is one thing from the periodic table. It's made of atoms, strictly atoms. For example, you could have something like gold or helium. Compounds are made of combinations. They're made of molecules. And so for my examples, I've given calcium carbonate, and iron oxide. Those are both compounds. They're made up of 2 or more types of atoms. This happens to be made up of a calcium atom, a carbon atom, and 3 oxygen atoms. The iron oxide, is just iron and oxygen. And so that is how they differ. The basic unit of a compound is a molecule. The basic unit of an element is an atom. The last bit on the back of the front page is describing a scientific experiment from our class. And this is sort of going to be on your own. You can pick any topic that we've covered, any equipment that we've used, what was the independent variable, what was the dependent variable, and then state a hypothesis. If you can't remember one, look something up. Look up some gas law experiment, or look up some titration experiment, something like that, and give me some of this information. Give me a table with the independent variable and the dependent variable. Give me a graph of what you think the relationship might be. If you need extra information like what is a hypothesis, take a look in Unit 2. That's where this material is covered.